Hello everyone, October 9th. I'm here again. So the calendar still need to work on that. Let's do the challenge first. What do we have? Break a palindrome. Oh, we've done this before. Given a palindrome, replace exactly one character with any lowercase letter so that the resulting string is not a palindrome, and that it is the lexicographically smallest one possible. Return the resulting string if there is no way to replace a character to make it. How is that possible? Oh, if it's a single, return an empty string. String A is lexicographic. We know what it is. Alright, ABCCBA. We want to replace it such that it becomes the smallest. So replace B with A. Exactly. There are many ways to break. Yeah, so we want to break as early as possible. This cannot do. Yeah, so given a palindrome, right? All we need to do is to go from the front and then find out the first letter is not A, and then we turn that into A. Like, what else? And if, in fact, if a string itself is A, and there's no way, like this, there's no way. Whatever you change, hold on, B. Yeah, I was like, it has one. That's B. It can. So we just find the first one, we change into A. But if it's all A, then we change the last one. And if it's a palindrome, and then, because it all match, because we want to change it as early as possible. So all A, and then the first one that's not A. Oh, but if it's like this, right? This is another case. This one, they cannot change this to A, because if you change this to A, it becomes a palindrome again. So for this one, I think it's also the last one changing to B. Because if we change this, it's actually bigger. So it's also the last one changing to B. Yeah, it's also the last one changing to B. So what's the rule? I mean, before we pass the halfway point, if I can change something into A to break it, right? Then we do it. No question about it. But if we pass and then we still cannot, and the only thing that will happen if we pass and we still cannot do anything, yeah, if it's an odd number, right? If the length is odd number, then you have to be very careful, because the middle one, if you change, it will still become a palindrome, right? So you have to be very careful. Okay, so those are the rules. Let's do this. Let's see if we can hit all of them. So we'll go for the first half, right? So divide by 2, 3, right? Hold on, let me try it. 1, 2, 3, 4, 5, 6, 7, right? 0, 1, 2, 3. Oh, that's not gonna work. So I have the length minus 1 divided by 2. Right? So if it's 6, minus 1, 5 divided by 2 is 2. So 0, 1, 2. Yeah, so we want to go for the first, and if any one of them is not A, and I can guarantee that we can just swap it. Right? So we say for I in range, len, let's do n equals to len palindrome, range n minus 1 divided by 2, right? So if palindrome I is not equal to A, then we can just return palindrome I to I, but not touch I, plus A plus palindrome I plus 1 to the end. So that's that. And if they're all A, right, then we just return palindrome this plus A. Okay, this kind of is my way of handling this. We'll see. Oh, hold on. What if it's a single A? If it's a single A, this one doesn't go. And we will just, if it's a single A, so if palindrome is equal to A, return empty. Oh, actually, any single letter cannot do. I just realized. B you cannot change. If you change it to A, that's still a palindrome. So that's exactly. So it's this. If n is equal to 1, we always return this. And if it's equal to 2, then you can do, right? AA will become AB. CC will become AC, right? Something like that. So let's try. So we have ABC, CBA, right? This one should be AAC, CBA. Easy case, A should be this. AAAA. This should be AAAAB, right? And AAAB, AAA. This one shall be AAAB, AAB. Oh, you didn't cover that case. Huh. This should be B, because the previous is all A, right? Previous is all A, so it should be B. Okay, let's see. Palindrome. Break palindrome. Yeah, we can generate test case for this. Import. Yeah, we can do randint, it's okay. All right, for this in range, I don't know, let's do 10 test cases. Each one 1,000, I just do 100. So we're gonna do, no, let's do half of it, right? Half of it, say half equal to the join character 97 plus randint 0 to 26, 0 to 26, it's actually 25. Yes, for this in range, let's do 5, which is fine. Right, that's half. And then mid equal to this if randint 0 to 1, else char 97 plus randint 0 to 25. Yeah, I feel like using choice will be easier. And print plus half plus mid plus half reverse plus where? If this, else character this. In line 2, unmatched, I probably did too much. There we go. Oh, this will be very easy. These are easy cases. I just changed the first one. These are easy cases. Let's restrict it. How about this? You know what? Let's restrict it to this. Even better. Okay. And how about extreme cases? All right, should be right. Oh! I got a wrong answer. What? A, B, B, A. A, B, A, right? Huh? A, B, B, B. Preposterous. 4 minus 1 is 3. 3 is 1. 0, 1. If it's not equal to A, I shall return A plus A plus... What the hell? I don't understand. Wait, what's... Yeah? Shouldn't it be 0 and 1? Hmm? The hell? I is 0. I don't understand. What the hell is this? Yeah, this is 1. Oh, 0, 1. We don't get 1. What the hell? Wait, I checked earlier. 6. 5. 5 divided to 2. 0, 1. Oh. Alright, my bad. 7 divided by 2 is 3. 0, 1, 2. Oh, I just n divided by 2. Ah, that's a silly mistake, huh? But how does all those things pass? Should be this. N divided by 2. Yeah, I don't know what I was thinking. I don't know. Pretty stupid if you ask me. Tiny little mistake. All right. 1328. Check the first half of palindrome. If any letter is not A, swap it with A. Otherwise, we only swap the last letter with A. Edge case is when the palindrome has the length of 1, in which case no, it's not breakable. All right, done this. All right, go back to the calendar. So I have this idea, right? And it didn't work out, but I'm still trying. Right? I'm still trying. So we still sort, right? We just go back to the basics, right? The data is just start, end, start, end, start, end. And we sort based on the start, right? And then I binary search to know where my current start is going to be. So everybody ahead of me, everybody before me to the left, if they are right, is larger than me. Right? If their right is larger than me, then I can count myself. Right? So for me, for this addition, I will do all those. So that's that. And everybody after me, right? Everybody after me. And I need to compute. Oh, how do we compute everybody after me? Because their value might increase as well. Well, their end, so their start will be larger than me, right? If their start is larger than me, and before I come in, so their chance of counting will be smaller than me because I'm smaller than them, right? I'm smaller than them. So I shall have the highest count no matter what, because they are larger than me. So there's a less of a chance for them to catch up, right? So the most, they're the same. Yeah, and most, let's say, because before I come in that position, that one will have, like, say, if it has the same amount as I do, right? And then I come in, so with the same amount, and I include myself, so it's that amount plus 1. For that, it could be that plus 1, right? But if it's a smaller, then it doesn't get. Or if it's larger, so yeah, I do think all I need to count is the new one. I don't have to count the other one. So I sort it, I bisect right, get the index, and I go from start to index because everybody will be, yeah, so we go start to index and everyone added to this, right? And then we say self.k equals self.k, a maximum, right? Self.k res, and then we return self.k. So I don't do any of the other things. So this is my new thing. Let's see if this one works. Oh, I forgot to add it. My bad. Self.data dot append start and I have to add it. Holy crap. Ain't right. So So 1, 1, 2. So we were right up to here. Alright, so 515. Oh yeah, 515 come in. Oh, I cannot focus on 5. Yeah, you're right. You're right. Yeah, when you go to front, it's the ones after you. Those gets incremented. Let me think again. And then I just go through all of them then. How about I get a map. I say count. Alright, so I have a counter. So what we did that is sort this, right? Then we say we do this. And we have to do this at the end, sure. Okay. Then we say self dot count start plus equal to res, just because this is a new thing at this position, plus equal to res. I don't do this here. Plus equal to res. And then I go, let's say for j in range, index towards len self dot data, right? Then for everything we check it. No. That's not right. For that is not data nor sort. I'm thinking. So everyone, so at this position, I see, and then we'll plus equal 1. Plus equal 1. Maybe it's right. Right? From index to the end, and its start equals self.data j 0. So if s is smaller than and self.count s plus equal 1. And then we run through, or I can just say int s smaller than and. Alright, so I run through all this, add it, and now I return maximum self.count.values. How about this? So this one I consider both. Yeah, I do need it, so. Preposterous. Now we have too much. 1040 comes in. Okay, so I have 10. The previous one is 20. So this 10 has 2 counts. Yeah, this 10 has 2 counts. So starting from 10, it should be 2 counts. So I say this is not plus equal to, I say this is equal to. Okay, and then later on, I say starting from this, here how many? Okay, let's try. If we just say this is going to be equal to, does this make a difference? Okay, getting close. And then for everybody else, 1, 1, 2, 515 comes in. And we'll do this already. So instead of I think we're very close. We're very close. Just need a little bit. A little bit. We have data, right? And after we have data, I need to go through data without repetition. How do I do that? Well, you do that by by a set. What if we do a set, right? We say for s in set. For j in this, right? Self.data j 0. So put into a set so there's no repetition. Then try this. Try it. It worked. It worked. So this idea does work. Does work, but needs some ingenuity, right? So this idea finally worked. And we don't need this k because we never use it. So we maintain. So the basic idea, right? The basic idea is that we sort all the intervals, all the previous intervals by their start value. Then given the current start, we know where to insert it. For all the intervals with start smaller than the current start, the current start will produce, right? Will produce the number of intervals. Number of intervals that overlap with the current interval is equal to the number of previous intervals with their starts that overlap with the current interval is equal to the number of previous intervals with their starts smaller or equal to the current start and their end larger than the current start. After computing this, we save the count in a hash map. Then we proceed to process the previous intervals with start larger than the current start. Know that the previous intervals with start smaller or equal to the current start will not get any more overlaps. Yeah, for those intervals with larger start, we only need to check whether their start is smaller than the current end. If it is, we can produce one more overlap for it. Another important thing to note is that for this to work, we must use unique starts to avoid double counting. So what we can do is index is this, right? And we say for I in range index, I'll sum this plus 1. Yeah. And no need to submit again. It's the same idea. All right. The time complexity of book is on log n. Log n for sort, right? This is log n. This is on. This is on. This is on. Sorry, log n. All right, take a look at the solution. Sweep line. O n squared. Segment tree. Yo. Balanced tree. And what is this solution? You know what? Put this solution up. We'll call it binary search. Yeah, it's not really readable, right? Yeah. Let's revert this. Readability is very important. It's not readable. We call this binary sort, binary search, and a counter, and a hash map for counter as counter. we can use binary search to find where to insert it. Equal to the number of previous and sorted after sort. The start smaller equal to the current start. We save count of overlap for the current start in a hash map. We proceed to process the previous intervals with a start larger than the current start. Largest start, only need to check whether their start is smaller than current end. This produces overlap for the, this produces overlap, right? Can produce, oh, I did expand it. It is, we can produce one overlap for it. But I still want to read to solution. Alright, so I'll call it today, but I think this one deserves a little bit more investigation because there are some things I don't know. Sweep line, now what the hell is sweep line? Segment tree, we know segment tree, I want to see how this one can be used. And I'm actually wanting to practice segment tree. Yeah, so we'll do this tomorrow. And balanced tree, oof. We'll do balanced tree as well. Good problem. Okay, so we'll leave this one here. Let's solve one more problem. How about that? We have an easy problem here. And just get this one done. Then we call it a day. Find greatest common divisor of an array. Interesting problem. Given an integer array, return the greatest common divisor of the smallest number and the largest. Huh? What? We can GCD it, right? Yeah, I don't think this one even deserves a separate thing. I can just say return math.gcd min nums and max nums, right? That shall suffice. Unless you want me to implement GCD, that's a different question. Right, you're not asking me to implement GCD. Well, how do you implement GCD? See, that is a little bit challenging. Yeah, we'll do this one first. Hold on. Yeah, I don't see any trick in this one. GCD. Why it's so slow? Let me try it. Interesting. I mean, I know how to do it in the past. I might still remember. So if A is smaller than B, we want A to be bigger. So A, B equals BA, right? We want A to be the bigger one. And we'll return GCD A, now the smaller of the two, and this. So we can do this. Holy crap. 0. Oopsie doozy. If B is 0, return A. I forgot. Yep. Yeah, I still remember how to do GCD. No way! How is this one so much faster? Whatever. I still know how to do GCD. That's reassuring. All right, that will be it. I will see you guys tomorrow. Adios.